All right, this video is going to talk about reading histograms, a little bit of standard deviation, and looking at finding percentages from a chart. So number 5 on our review, we have a histogram below that shows the GPA of random high school students in 2003. So we see, the GPA of the student is along the x-axis, and then the frequency of, how many students were in that class. Um, that's along the y-axis. So first we want to figure out what percentage of students have a GPA of less than a 2.07. So one thing we need to know is how many students do we have total. So if we add up all of the tops of the bars here, so like this first bar goes to 1, then 3, 5, 6, 7, 8, add up all of those, and we see that we have 31 students total. Now, we want to know how many have a GPA that's less than make that less than a 2.0. So 2.0 is right here. So less than that, we've got 3 in the 1.5 to 2, and then 1 in the 1 to 1.5. So we have 4 students out of 31. So we're going to take 4 divided by 31, gives us 0.129, which is 12.9%. Now, what percentage of students have a GPA that's 3.0 and up? So now we go, so the 3.0 to 3.5 and up. So we're adding 8 plus 6 plus 2. So we've got 16 out of 31, which gives us 0.516, which is 51.6%. Now, Kristen is the student with the median GPA for this sample. So the middle, right? We want to figure out what class or what range Kristen is in. So we're using that formula here, which is n plus 1 over 2. This gives us the location of the median. So in our case, n is going to be 31 because we have 31 students. So we're going to do 31 plus 1 over 2. So that's 32 over 2, which is 16. So now we figure out where the 16th location would be. So if you kind of count from, your tops of your bars here. So we have 1 plus 3, 5, 6. If you're counting up, the 16th is going to be in the 3 to 3.5 GPA range. All right, number 6 and 7 talk about standard deviation. So first, number 6 asks, what is the standard deviation a measure of? So standard deviation is a measure of how spread out your data values are. So if we have like a higher standard deviation, that means our data values are more spread out. If our standard deviation is very small, that means our data values are very close together. If our standard deviation is a 0, that means they're not spread out at all. They're all the same values. Number 7 says when finding the standard deviation, one step is to square the distance found when subtracting an observation from the mean. Why is it important to square this value? So one thing that's important is standard deviation is always it's always positive. So we can't have a negative standard deviation. When we square the differences, when we were subtracting, we had a difference, we squared that, that made it positive because we can't have a negative deviation. All right, number 8 is similar to one we've already done. So we see we have a table and it has kind of like the age group, has a number of people that are within each age group. We want to find the percent of the people, round to the nearest percent. So we see that the total is 250. So we start in that first class, which is ages 15 to 24. We have 55 people out of 250. So you're doing 55 divided by 250, which gives us 0.22, which is 22%. And we have 92 out of 250, which gives us 0.368, which would be 36.8%. But we're rounding that to the nearest whole percent, so make that 37%. Let's see, 35 to 44, we've got 61 out of 250, which is 0.244 or 24.4%, but we're rounding, so 24%. And the last one is ages 45 to 54, so we've got 42 out of 250, which is 0.168, which is 16.8%. Rounded up to the nearest whole, we're at 17%. All right, and the rest of this problem, let's see, we've got the questions and I kind of copied over our chart. So it says, how many classes does this data have? So that is the age intervals. So we see we've got 15 to 24, 25 to 34, 35 to 44, and 45 to 54. So that means we've got 4 classes. Now, what type of variable is this? So it's either quantitative or categorical. Since we're dealing with numerical values, it is quantitative. Now, we're looking for the class width for this data. So we go from 15 to 24. So that means we're including ages 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. If you were counting those ages, it's going to give us a width of 10, so 10 years. The spread of the data, think of that just as the range, which is just the biggest number minus the smallest. So in our case, that is 54 minus 15, which gives us 39. So our spread of the data is 39 years.